Once again, welcome to viewers. In this video, we will discuss a few important sums on tangent to a circle. This we are taking from exercise 10.2 Cbse class 10 curriculum. Now question number 5 is prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Let's say PT is a tangent to this circle at center C. Now we have to prove that perpendicular at T passes through the center C, right? So we have to prove that CT is perpendicular to PT, right? Now let's say perpendicular does not pass through the center. We assume that there is another line which is perpendicular at T. Suppose let's say this line is perpendicular at T. That means we are assuming that this angle is 90 degree. So let's say this is TA, this chord which is perpendicular to the tangent PT at point T. So we are joining center C with A, and we are joining center C with T. Then let's take the middle point of AT. Suppose this is point D, suppose. Then we are extending DC to a point, suppose this is B, suppose, right? So these are some additional construction. So we are assuming that let us assume perpendicular at T does not pass through C, right? Perpendicular at T, suppose we are assuming that it does not pass through C, and chord AT is perpendicular to PT. This chord AT is perpendicular to PT. Then we are joining AC and TC are joined. Midpoint of AT means D. Midpoint of AT, that is D is joined to C and it is extended to, suppose, B. DC is extended, it is to the point B. That is AD equal to DT, right? Now AC equal to CT, they are radii of the same circle. This is common side, CD equal to CD. Now in triangles ADC and TDC, you find that AD equal to DT, D is the midpoint. Since D is the midpoint, right? D is the midpoint. AC equal to CT, radii. Then you find CD equal to CD, common side. So triangle ADC congruent to triangle TDC by SSS congruence criteria, right? So you find that angle ADC equal to angle TDC, CPCT. Corresponding parts of congruent angles are equal. Therefore, these two angles are right angles, right? this is suppose angle 1, this is 2, angle 1 equal to angle 2 equal to 90 degree. Now let's say this is angle 3, this is 4, and this angle equal to say 5, and this angle equal to say 6. Now angle 1 equal to 2, we find that angle 1 equal to 2 equal to 90 degree. Therefore angle 3 plus 4 equal to 90 degree. In a right triangle, sum of the acute angles 90 degree. They are complementary angles, right? So angle 3 plus 4, 90 degree, right? Angle 3 plus 4, 90 degree means therefore angle 6 equal to 90 degree. Exterior angle equal to sum of interior opposite, sum of interior opposites. Angle 6, it is the exterior angle for triangle TDC. Therefore angle 6 equal to 3 plus 4. Since 3 plus 4 90 degree, angle 6 90 degree. Now angle 1 plus angle ATP equal to 180 degree. Why? It was assumed that AT is perpendicular to PT. That means angle 3 plus 5 90 degree. Angle 3 plus 5 90 degree. Right? Angle 1 plus ATP means angle 3 plus angle 5 180 degree. Right? Now if angle 1 plus ATP is 90 degree, this means that BD is parallel to PT. You don't need to write this line. Angle 1 plus ATP 180 degree means BD is parallel to TP. Why? You see, you find that this angle 1 and this angle, this is DTP, and this is B. Angle 1 plus this angle 180 degree, that means this line is parallel to this line. Interior angles on the same side of the transversal are supplementary, that is BD is parallel to TP. BD is parallel to TP. If BD is parallel to TP, then you find angle 6 plus angle 5 180 degree, right? Angle 6 plus angle 5 180 degree, right? Now angle 6 plus angle 5 180 degree, angle 6 equal to 90 degree. Therefore you can write angle 1 plus angle ATP equal to angle 6 plus angle 5, that is angle ATP equal to angle 5. Since angle 1 equal to angle 6 equal to 90 degree, so we can cancel out these two equal parts. Angle ATP equal to angle 5, or angle ATP equal to angle 5 means angle CTP. But from figure you see, angle ATP and angle CTP, they are two different angles. So our assumption leads to a wrong conclusion, right? If we assume that AT is perpendicular to PT, that means if we assume that the line which is not passing through the center is perpendicular to tangent at T, then we find that angle ATP equal to CTP, which is not possible, right? ATP and CTP are different angles, which is not true, right? And that means our assumption is wrong. That is, our assumption is wrong. What was our assumption? Chord AT is perpendicular to PT. Now, when can we say ATP equal to CTP? It is possible only when the line AT and the line CT coincide with each other, right? ATP equal to CTP is possible if AT coincides with CT, right? So AT must coincide with CT. That means perpendicular must pass through the center. That is, perpendicular at T passes through center C, right? Angle ATP equal to CTP is possible only when AT coincides with CT. That means perpendicular at T passes through the center C. So this is how you can prove this. Now let's come to another question. Prove that angle between two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Let's draw a circle here. This is the center. Now, from an external point, let's say this is an external point. We are drawing two tangents. One more tangent at this point. Say this is P A and P B. So given PA and PB are tangents at A and B of the circle centered at C. C is the center. Now, angles between two tangents drawn from an external point. What is that angle? Here, APB, this angle. Now we have to prove that this angle is supplementary to the angle subtended by the line segments joining these points of contact at the center. Now, what is the point of contact of this tangent PA? A. So you join this point of contact to the center A, C. This is AC. Then point of contact of the tangent PB is B. You join with the center. That means you join BC. Now we have to prove that this angle and this angle, these two angles are supplementary. Means sum total is 180 degree. Right? To prove angle APB plus angle ACB equal to 180 degree. Now, in a quadrilateral, you know, sum total of all the four angles of a quadrilateral is 360 degree. You remember this? Now, again, you find that a tangent is perpendicular to the radius through the point of contact. This angle is right angle. Similarly, this angle is also a right angle. So sum total of these two angles you find 180 degree. That means the sum total of remaining angles will be 180 degree. That means these two angles are supplementary. So let us prove this. We know that tangent is perpendicular to the radius through the point of contact. Through the point of contact. So we find that AC perpendicular to AP, that is angle CAP equal to 90 degree. Or you can simply write angle A equal to 90 degree. Similarly, CB perpendicular to BP, that is angle B is 90 degree. In quadrilateral APBC, we find that angle A plus angle P plus angle B plus angle C equal to 360 degree. It is angle sum property of quadrilateral, right? Just like angle sum property of triangle, sum total of three angles of a triangle is 180 degree, and sum total of four angles of a quadrilateral is 360 degree. Now we know that angle A is 90 degree. Angle P, we do not know what is angle P. Angle B is 90 degree, that we find 90 degree. Angle C, sum total is 360 degree. Therefore, angle P plus angle C equal to 360 degree minus 90 degree minus 90 degree, or angle P plus angle C equal to 180 degree. Angle P means you can write APB. Angle C means you can write it as angle ACB equal to 180 degree. So this was to be proved, right? So thank you viewers for watching this video. Keep in touch. We will discuss similar exercise in next video again.